All right, we're going to talk about solving inequalities. And what you'll realize is that solving equations and inequalities is the exact same thing. So we solve them the same way. We're still isolating the variable and doing the inverse operation to get our answer every time. So to prove it to you, what I've done is I have one column over here on the left that is all equations, and I have one column on the right that is inequalities. And I have the exact same variables, exact same numbers and operations. The only thing I've changed is I've changed the equal sign to one of our four inequalities. So I'm going to demonstrate it side by side just so you can see it. So our first equation is x plus 7 equals 10. Well, if I was going to solve this, I know at the end, my goal is to get x by itself, so I need to get rid of that plus 7. The way I'm going to do that, like we talked about last week, is the inverse. So the inverse of adding 7 would be to subtract 7. And we know 7 minus 7 gives me 0. And what we talked about last week with the seesaw was whatever I do on one side, I have to do on the other to keep my equation balanced. So 10 minus 7 would give me 3. So I know that x equals 3. Now, if we want to graph this on a number line, I'm just going to put a closed point right here, and I'm going to put a 3 right underneath it. That shows me my answer is just 3. All right, so inequalities is the exact same thing. I have x plus 7 is greater than 10. Well, I'm still going to do the same thing. I'm going to subtract 7 from both sides, which is going to leave me with x on one side and 3 on the other. The only thing you have to be careful with is I'm bringing this inequality sign straight down. X is greater than 3, not x is equals 3. So if I wanted to graph that answer, x is greater than 3, like we saw yesterday, I would put a open circle at 3 because x does not include 3. It has to be bigger than 3. And since x has to be greater than 3, I'm going to draw a line going to the right, which shows me my answer to my inequality could be anything greater than 3. All right, we're going to go on to our next one. I've got x minus 12 equals 3. Well, like we just did on the last one, I'm going to do the inverse. The inverse of subtracting 12 would be to add 12 to both sides of my equation, which would get rid of that on the left and leave me with just x equals, and we know 3 plus 12 is 15. So if I want to graph it, I'm just going to put 15 right there at the middle of my graph, and I'm going to put a closed point to show me that that is the only possible answer for that equation. Now we're going to solve the inequality the exact same way. I'm going to add 12 to both sides to keep my inequality balanced. I get rid of those two 12s, and I get x is less than 15. So again, I'm going to use an open point because x does not include 15. It is less than 15. So now I'm going to draw my arrow to the left. X is less than 15. Anything less than 15. All right, now we've got a multiplication equation, 5x equals 20. Well, we know the inverse of multiplying would be dividing. So I'm going to divide both sides by 5. And I know 5 divided by 5 just gives me 1. So all I'm left with is x equals 20 divided by 5, which is 4. So x equals 4. I'm going to put a closed point right there and to show that x is only equal to 4. That is the only value that would make that equation true. Our next one, same thing. Inverse. The 5s will cancel each other out since they're opposites. And I get x is greater than or equal to 4. Well, I have 4 down here. But now x is greater than or equal to 4. So I'm going to shade that point to show that x could equal 4, but it's also anything greater than 4. So I'm also going to draw a line going to the right. So x is 4 and anything greater. 5 times 4 is greater than or equal to 20. So is everything else that's greater than 4. And then our last one down here is division. So I'm going to do the opposite or the inverse of dividing by 4, which is multiplying by 4. We know 4 divided by 4 just gives me 1. So I'm just left with x equals 3 times 4, which is 12. And again, Equations are easy to graph. I'm just putting a closed point on the number because that's the only value that would make that true. And I'm going to do the same thing on the inequalities. Cross them out. X is less than 3 times 4, which is 12. X is less than 12, so I need an open circle because it cannot include the number 12. And I'm going to draw my arrow going to the left. All right, so you see they're basically the exact same thing. The main thing you have to remember is to include your inequality sign in your answer and not an equal sign. That's something I see people make a silly mistake on a lot.